Hey, welcome to BarryTsGarage once again. Here's another episode of Ask Ed, and we're going to get straight to it. I'm going to ask Ed your questions. Thank you for giving us questions to talk about. It's really a lot of fun. Hi there, Ed.
Good morning.
Good morning. Good morning.
Yeah, we like to answer some questions, and basically some of our answers are my opinion.
That's right.
Yeah, they're not necessarily the rules or anything, but it's just my opinion, and well, I hope I have a good opinion on answering your questions. So
right.
We'll try some.
Your opinion is part of the fun.
Yeah.
I think that's good.
We have fun.
That's
yeah.
right. We have fun.
Okay,
so I'm going to get straight into it here. We talked about the Caddy 472 and the 500, those Cadillac engines.
Yeah.
And someone asked, well, how would you compare the Ford 460? It's kind of in that ballpark of size. What do you think of that Ford 460?
I think the 460, I like that 460 motor.
Okay.
And it was lasted forever. And it was in the Lincolns.
Yep.
I had some Lincolns years ago that had 460s in it, and one of my customers had it on propane. And I think after 200,000 miles, there was no ridge on it at all.
Okay.
And it was like the motor was brand new, but it was in a Lincoln. And I think also Lincoln motors were a little different than the rest of them. Maybe some more nickel in the block, and I think they were balanced better because they ran so smooth in a Lincoln, a lot more than they did in some of the other things. And I think we had some of those motors in a boat. We had a boat for the kids one time. It was maybe an 18-foot, and we put a 429 Lincoln motor in it. And the 429 Lincoln out of maybe early 69, maybe, was 11-to-1 compression.
No.
From the factory. The single four-barrel, and that had a lot more torque more than a big block Chevy in a boat.
Really?
And we had a lot of fun with that boat.
Huh.
But 460 motors are good, except the Ford truck, until they retarded the camshaft in it. Again, we've talked about that in the other videos, that they retarded the camshaft in it when the trucks, to save the drive shaft and save the transmission, because it put out so much torque. And to fix those, we just changed the lower gear on the crankshaft, the timing chain gear.
Okay.
And if you look up anywhere, and in the books it says that the Ford 60s, and it said on the gear number, you could buy those gears and chains separately. And the bottom gear said police car gear was degree different. It was a half a tooth advanced.
Is that all you had to change?
Just the bottom gear.
Just that bottom gear?
Yes. And the other 460 gears, the dot didn't line up with the two things. It was a half a tooth off. And the 460 lined right up. So he advanced the camshaft a half a tooth.
Just that much.
On the gear, and then put it back on again, and the dual wheel truck would just smoke the rear tires. Just smoke them, just spin the wheels.
Okay.
And had that much more low end power.
Wow.
And that's advanced the camshaft again.
Okay.
Or retarded the camshaft.
So it's safe to say that you kind of like the 460.
I like the 460. Oh, they last forever.
Yeah.
I don't think we didn't have any valve problems or burning the valves or anything. And of course, they all came with 4-barrel carburetors on them.
Yeah.
And we could buy all kinds of carburation for them and stuff.
Okay.
Yeah, big ports. It was part of that design, I think, went into the 351M motors and the Boss motors with that round port.
Yeah, right.
The big ports, yeah. It was all awesome motor, yeah.
Okay. Yeah. Excellent. Well, that's very good. We've talked off and on about distributors. Yeah. Someone asked a question, could you have Ed explain what's the reason for having dual point distributors? What's the difference?
It's a little bit different, and there's some weird designs, but mainly one point opens and the other one closes.
Okay.
And that's to keep the points cooler. The point itself didn't get hot. If on that one point opened, and there was about maybe a few degrees difference when the one opened and closed. So one opened, the other closes 8 times on an 8-cylinder motor.
Okay.
Instead of one open and closing all the time, 8 times for a thing.
Oh, so it's spreading the load.
Spreading the load, spreading the heat, because they got hot.
Okay.
And usually when a point engine don't start, it's usually the points, and they'll get corrosion on the point.
Yep.
Just from like a slag on a welder. Because they cook together all the time, and they're made out of tungsten, I think, that little point on the end.
I see.
So sometimes the guy just brought me a 3240 the other day here in town that wouldn't start. somewhere, and I took the distributor out real quick, and the points were good. And I took a little sandpaper and put between the points and just went back and forth and cleaned that slag off there, like slag off of like a sparks off of a welder. Cleaned it all up and tested them, and they worked fine. Put the distributor out and fired right up.
That makes sense because, I mean, what else is going to make it rough? I mean, they're just touching each other. So,
but then I want to go back again on a Flathead Ford. They designed that a little difference and where they hooked it up. And if you take 1 point off of Flathead Ford's got two points.
Okay.
If you take one of them, it'll only run on 4 cylinders.
Really?
Yes.
Okay.
Yes, it's really crazy.
I didn't know that.
And I'm not an electronic engineer or anybody or how they designed that or what they did, but that's
how they did it.
And normally on a Chevy, if you have a melody distributor, you can take 1 point out and leave it out.
Okay.
It'll run just fine.
Yeah. Okay. We learned something there. Next question, it's about crankshafts. We got close to we were talking about the timing on the crank. So someone is talking about the 340, the Chrysler 340. There's fans of that engine.
Yes.
He said that it had a drop forged crank, whereas a lot of other competitors didn't. Do you know anything about that, or do you have any information?
Well, a forged crank is a forged crank.
Yeah. Okay.
Yeah. It's not a steel crank.
Okay.
Yeah. I think the 360s. I think the 340 crank and another one is the same crank. I'm not sure.
Might be the 360.
I think maybe in the 340s, maybe the same crank when they were different bore size to get from one to the other one. A forged crank is a hot crank stamped with a big machine. Right. And it's kind of crazy. We'll try to explain that a little bit the best I know how, and which I think I know a little bit about it. I wasn't never in the crankshaft manufacturing business, right? But a steel crank is a melted piece of steel, and they put it in a machine and it stamps it. Okay. And they're all stamped flat. And while they're red hot, the machine grabs the throws and gives it a twist.
Oh, really? Okay. Really?
Yes. It's called a twist forge. So it gives that crank a twist, and that makes them a V8. Okay, so off center, four different positions.
So that's how they move it into the position.
That's right.
Flat.
It'd be like kind of making a spindle for the front spindle for a car.
Okay.
It's a piece of steel, and they stamp it, and it becomes a piece out here for the wheel bearings to go on, and the others for the 2 ball joints. Right. And while it's still hot, this machine grabs it and bends it, and then they can machine it for the ball joints and the spindle.
Okay. So going back to the crankshaft,
it's stamped hot, and the machine grabs the throws and twists it.
Okay.
And then it's made to a V8 then they can machine it back to rod bearings and main bearings.
Sure. Okay.
So in our engines, if you're going to be picky on them, then because this forged and twisted, if you can run that motor a lot, it wants to unwind.
Oh, it wants to go back to its original state.
Yes. It may go back a little bit, and pretty soon your engines are not precise timing between 4 pistons here and the other 4.
Okay.
So that's why you take a steel crank, a piece of billet steel, and start putting on a lathe and make all kinds of shavings and come out with these big crankshafts that cost $5,000 for a crankshaft. A steel crank, yeah.
Okay, and now that what you're talking about, is that like a billet style?
Billet, that's right, exactly right, yeah.
Okay.
So if you understand that, I'd like to see that machine run sometime.
I would too.
Where it would twist that crankshaft.
Okay.
Yeah.
Boy, I never knew that.
Yeah.
Interesting. Okay. All right. Now, you talked about the Ford 460 going forever. Here's a question about going back to the Ford Flatheads. Someone named Greg said, how many miles do you think Flatheads would go before they would need to be rebuilt back in the day?
I don't know. Some of them, let's go back to the history of the Flathead. It was probably the first motor, but they really didn't. It was a pleasure car. When they got done, it was just a pleasure car, and they still had horse and buggies and things like this, and they went there, but they didn't go very far. You only drove it 5 miles to town or 10 miles to town. It was rare for them, and once in a while you seen somebody would go from Indiana or something to drive to Chicago or something. That would be a 2-day trip or something, and to go to Denver, Colorado, that would take you a week and a half. Right. And things back. So they really didn't use the car like that. And then we go back to the filter system, the air filter system, and keep the thing clean on our dirt because most of it was farmer, dirt fields and dirt roads then too.
Right, and their oil bath wouldn't catch everything.
The oil bath wasn't, that wasn't that good of an idea or something.
Right.
But as far as the length of the motor, it was just still a V8 motor, American made thing, and if you took care of it, it would last a long time.
Yeah.
But I see some of these motors that they had some different things like there's all kinds of stories you could hear about that. But probably I would think maybe 50,000 miles.
Yeah.
I think would be a good mileage. And if you got 50,000 miles on a Ford Flathead motor,
you probably did pretty
then it
well.
would need some rings, especially rings.
Right.
And the oils they had then probably wasn't near as good as what we have now.
Right.
So that would short-live the motor there. They just had 30-weight oil.
Yeah.
And so in those days, it was probably non-detergent oil.
Right.
They didn't have soap in it.
That's right.
Detergent soap. So you have to take that all into consideration. 50,000 miles is probably a good thing, yeah.
And incidentally, I'll just mention, if someone's really interested in Flathead Fords and all the little minute details, our friend Steve Kopic just did a video explaining all the little differences, and the 32 Flathead is quite different than a 52 Flathead.
Yeah, right. Yeah.
They changed them along the way.
Yeah.
Okay, so do you know what B&M is? Something about a shifter? This is kind of a random question. They had shirts you could get in a can of trick shift. I don't even know what that is.
Well, okay, there's trick shift oil.
Okay.
B&M transmissions in California. They were big. They were the first ones to kind of do this. The hydromatic transmission, the old GM Oldsmobile 4-speed transmission, a big cast iron one.
Oh, right.
That was a B&M. So we had a B&M transmission. Was the best you could buy, maybe.
Okay.
I'm going to put a big fat maybe on that too.
Okay.
And so they did some engineering, and so then they went on to building transmissions, and even in the torque flights, and later on, and they end up having their own transmission. And the oil, they took, as far as we're concerned, B&M oil was Ford oil, because we know the transmission oil of Ford was a dry oil, so it shifted harder.
Yeah.
And then the GM oil was a slippery oil. You're supposed to put that in a B&M hydromatic for the old lady with the Cadillac in it. Not the old lady, but a young lady with the Cadillac. And then she wanted it to shift nice and smooth.
Right.
So they put the slippery oil in it. But so the B&M oil was Ford oil with some blue coloring in it.
Okay.
So nice blue coloring. And the B&M shifter, then we go back to that, B&M started to make some shifters other than mechanical. They put a cable on it. Then there's all kinds of cable shifters, and there was different safety things with park. And then you could only shift one gear at a time. You couldn't. It was impossible to go from one to the other. You had to move the lever over and go to the next one, move the lever over, and move the lever over. So there's some tricky shifters, and they were all B&M. So that's what
I see.
And they were quality works, quality shifters. Yeah.
Okay.
We have some, and I have one special one over here that's there's 3 levers on it, and all 3 levers, 3 rods sticking up with balls on them.
Really? Okay.
Yes. So the first one was first gear, and second gear, and third gear. It was more like a Lenco out of a funny car. But they copied that a little bit, and I have one of those shifters over here.
That's really cool.
Yeah, it's kind of cool.
Yeah. All right. Well, this falls right in line with the B&M. Someone says, I know Ed's usage of the term oil, but actual petroleum is not really good in an automatic transmission. It's more of a, he's saying that it's a fluid technology. I don't know. He doesn't like calling it oil, but it's a lubricant. I don't know what you call it.
Synthetics, some people call it synthetics, but all oil is an oil-based material.
Yeah.
Even though synthetic oil is still an oil base.
Right. Okay.
Yeah, it is.
And then we had another person asking, they were trying to be clear. You talked about in a previous video about putting, like you just mentioned, the Ford transmission fluid, using that in the GM 350.
Yes. Yeah.
Which models of transmission would that be okay in?
All of them.
All of them up until today?
Yes. Yeah.
Really? Okay.
Yeah. I don't know. My new truck, I don't know. I'd have to think about it, whether I put Ford oil in it or not.
All right.
I have a transmission guy that rents down the street here a little ways, that rents a building from us, and he's a younger transmission guy, and he seems like he does a lot of work. And so I would ask him a little bit about it before I did my own.
And is this the one, at least the ones you're familiar with, Is that the Ford Type F?
Yes.
Okay.
That's, yeah, Type F. Yes.
Type F.
Yeah.
Okay. Just want to try to clarify some of that. All right. Okay, now I've got two people, both with carburetor. Again, this is Ed's opinion, so, we're going to talk about carburetors. He said, I've heard a lot of people say Rochester Quadrajet is the greatest carburetor ever existed, and some people prefer Hollies and Edelbrocks because they don't have the necessary skills to take advantage of the Quadrajet.
Quadrajet is an important and interesting carburetor.
Okay.
I like them on particular applications.
Right.
Yes. I have one over here that I've done a lot of work to, and you can make them run really fantastic.
Okay.
And we have done that
Okay.
on some of our circle track cars you have to run a Quadrajet on them.
Okay, like a rules.
Yes. And even our drag cars. Earlier we had a particular class, we had to run that stock carburetor.
Okay.
I think there was a guy here in town, his last name was Young, maybe, and he rebuilt carburetors and he moved to California. This is 1970s or 80s.
Okay.
And built carburetors, and his specialty was Quadrajets. And you get into that Quadrajet carburetor again with that air bleed system on that. And again, I know quite a bit about Quadrajet carburetors, and I like them.
Okay.
On the particular application.
So it's probably like a lot of things, and I know
they're good for their own purpose.
Right.
And they're fantastic.
Right.
Yeah.
But you can't make a blanket statement, this is the best for everything.
Oh, no, you can't do that.
It doesn't work like
that. It's like our Cadillac, our carburetors we like to put is 454 Chevys, a little bigger Venturas, or else a 500-inch Cadillac carburetor.
Okay.
A little bit different. And then the air bleed things that is important on a Quadrajet it's really strange.
Okay. Yeah. You're going to have to show us one sometime.
Yeah, I might do some where we've done a little...
Well, we've talked about doing a little carburetor videos.
Removing some parts of the Quadrajet, and there's one thing that's got a whole bowl on one side. It's got a little hole in it. If you drill that hole in it, when the float bubbles come up, it would actually fill this other chamber. So now the carburetor would hold almost twice as much gasoline in the carburetor.
Really?
One of those tricks like that.
Uh-huh.
Yeah, so.
Can't wait to see that.
Yeah, nothing wrong with the Quadrajet.
All right. Good answer. I like it. I found a guy that uses Rhoads lifters at high RPM. So it sounds like there's some way where the lifters behave differently.
Yes, we know a little bit about that.
Okay.
And Rhoads lifters are actually, I think they're made here in town, Phoenix, Arizona. That's where we're at.
Yep.
Talking about Phoenix, Arizona, where we're at today.
Yes, that's
and
right.
I had a customer come in the shop the other day, walked over and around my bench, and he just stood around and stared at me. He says, "You're the guy with the videos." Yes, I didn't know you were in Arizona.
Right. We don't talk about it that much.
And he's been in one of our customers, and he's been in the shop many times, and we're building a motor for him. So it was one of our customers that came in the corner and seen me messing around with my bench.
That's
so
funny.
It shocked me, and he was shocked too. So, but we are in Phoenix, Arizona. But lifters were made here in town.
Okay.
And I think they moved up. The guy retired and moved up to one of the retired communities up north in the Rim.
Okay.
And I think he still makes them. Maybe he don't make them.
Okay.
But actually, they took the lifter and machined a groove in it.
Oh.
Yes, inside the lifter. So at low RPMs, that oil would bleed off and make that lifter like it was a half a hydraulic lifter.
Oh.
Yeah, the lifter floated a lot more and keeps instead of being high. The lifter bled the oil off of it at slower RPMs. Then when you revved it up, the oil pressure would overcome that. From the oil pump on, let's say you had idle or low pressures, you had 30 pounds of pressure, oil pressure. And then when you speed it up, then the oil pressure would overcome that groove and pump the lifter up.
That makes
sense.
sense.
We know a Chevy lifter has about 1/4 of an inch of play in it.
Okay.
And you could actually get ready to set of lifters. If you put one in the vise, an empty one, it would go down 1/4 inch.
Okay.
So if people says, well, we adjust my lifters with no play, loose push rod, tighten the push rod, and give it a 1 turn.
Okay.
You could actually go 4 turns. It'd all be the same. As long as it floats in that oil. It could float here, float here, float here.
Because the hydraulic pressure of the oil is going to do it.
That's right. A standard lifter forever.
Yeah.
Now with that groove in it, they cut a groove, the lifter starts to bottom because it's bleeding off.
Okay.
You rev it up, it goes up higher. The lifter pumps the lifter up to the top.
Right.
When it pumps up the lifter, we'll hold the valve open a little bit more.
Uh-huh.
Correct. But sometimes at idle, they might be a little noisy.
Okay.
Yeah.
So that would be the one possible downside to it.
That's right.
Okay.
Again, back when I was a younger, we would take the lifters apart because we had to run, NHRA told us we had to run a stock lifter.
Okay.
Hydraulic in a class.
Mm-hmm.
So we took the lifter apart and a little washer in the bottom and put the lifter back together. It was still hydraulic. But when we did that, the lifter was only a quarter of a turn adjustment variance. So if you turned down a quarter of an inch, you held the valve open. If you held the other quarter inch and turn this way, it would clatter because the valve would be loose.
Yeah.
So right in that area, and the engine would go about 500 RPM or more in a stock car, 1960 Chevy El Camino I was racing then or something.
Oh yeah, right.
We get another 500 RPMs on with those, with the washers and the lifters.
Yeah.
And that was all legal, I think.
You didn't ask.
No, I didn't ask them. They didn't ask me. But that was a hydraulic lift anyways.
That's awesome.
Yeah.
Okay. Next question from a guy named John says, we had an 87 Malibu with a 267 V8. Put a 1-inch square piece of metal in front of the cam, 1/8 thick. Reduced the camshaft walk at high RPM, shimmed the drive gear on the distributor, put a clutch fan on it, and we were beating 350s. I don't know. That's a lot of monkeying around. I don't know. If
I don't understand that. I know there's a 267 V8. It came out a little Chevy Malibu or something.
That's right. That's what he said. Chevy Malibu.
Yeah, a Chevy Malibu or something like this. And I think, I can't remember, I think whether it had a 2-barrel or a 4-barrel carburetor on it. I would possibly think it had a 2-barrel carburetor on it. Mm-hmm. And probably at that time, I don't know what year it could have had a Power Glide transmission in it too. They were trying to build something as cheap as they could and trying to get some kind of gas mileage out of it, but it didn't have any horsepower.
Yeah.
And so it was rare to see one of those motors. Okay. We don't see them today. I haven't seen one of those motors for probably 20 or 25 years.
Yeah, I haven't either.
Yeah, I've never heard of it even. This is the first guy that...
Okay. Well, anyway, he's talking about in the past too. This was past tense. We used to have. So, okay, next.
You should get over it and just buy a good 383.
There you go. From 5-star engines.
Yeah, from 5-star engine, yeah.
There you go.
Yeah, I'd be much more happier.
Oh, goodness. All right. This is more of a comment. He says, Ed's right on. His first car was a 55 Pontiac. He built it for drag racing. It took 3 batteries to start it. It had a 389 3-speed stick. So was that common with people that have things cranked up so tight it would take 3 batteries to start a car?
There's a lot to enter that thing. He had a 55 Pontiac?
Well, the 389 wouldn't have been stock, obviously.
Oh, no, that wasn't. But then you get into that 389 with a big bore. If you didn't have the ring gapped right, the end gaps on the ring, every time it got up to 180 degrees or something, it would run for about maybe 2 miles at 180 degrees, and the ring got tight. It would peg the temperature gauge and boil it right there. Wow. And the engine would stop, and it wouldn't start for a while.
Wow.
If that was the case. It cooled off and started back up again.
Interesting.
So the rings were way too tight, and the piston bore was too tight.
Okay.
Yeah, and that, if I would run that big Pontiac, and we would do 440 Dodges and anything with a big bore.
Right.
We're talking 4 1/8 or 4 1/4 bore or something like this. We'd like to run them instead of 30 over, we run them 31, 32 over.
Just give them that little bit extra.
Yeah, just a little bit extra so they don't get heated up.
I see.
But and then starter, you had to do that. And then if he's a drag car, where you put the batteries in the trunk, and had a 8-foot battery cable, and also the what size ground cable he had. They had the ground cable bigger than the positive cable.
Right.
So then it ain't going to start either.
Right.
So I don't know. He had several problems there that it wouldn't take too much to get it straightened out.
Yeah.
He'd have to probably take the motor back out.
All right. Here's a question right up your alley. The 377 small block. A 400 block and a 350 crank is a much better motor. A 383, that's a 350 block and a 400 crank, is less desirable, long stroke, smaller bore. He's saying an engine builder would know the bigger bore, shorter stroke is best. You know, Ed, you have your opinions? And
I have my opinion on both. 377 is really a good motor.
Yeah.
If you want to that would be good in dirt tracking again,
Okay.
where you're going to place your car in the dirt track and how long the track is.
Okay.
You know, a little short track, the 377. Oh, he loved that 377 motor.
Okay.
It was a quick RPMs, a short track.
Okay.
And the 383 would be a long track, or 3/8 track or bigger. And sometimes 3/8 tracks, they said it was 3/8 track, and it might have been the inside of the track. So this, we're calling a long 3/8 track, because they measured inside the track and then not the outside.
Right.
So then if we want to move the outside, I'd run a 383 motor right away.
Uh-huh.
Of course, our half mile tracks, we run the 434 motors.
Okay.
You know, because that was go down you had a quarter mile down the street. So that was it. Depends on where they were at. They were awesome motors.
Yeah. So it goes back to, again, it depends on what you're doing.
What you want to do. Yeah, exactly. If you pick the right motor and the right car, you probably win the race.
Right.
But I know a little bit about that, winning the race.
You've won a lot of races.
I've won a few, yeah.
That's right. Okay.
I hope that answers this question.
Yeah, I hope that does too. Yeah. Okay. Okay, next question. We're moving on to the 351 Ford Cleveland. Someone says, does anyone know any solutions for crank oiling issues on the 351 Cleveland?
I don't know of any issues at all.
You don't? Okay.
No,
so maybe he's having his own issues. Maybe that's a specific problem.
Somewhere in that 351 Cleveland motor.
Yeah, that's that bigger block.
Yeah, that would be almost the M motor. I don't know, no oil. I think somewhere along the line, some people have oiling problems. They need to figure out what they're doing with their oil pan.
Well, that was his follow-up question. Should we increase oil capacity?
Yeah, see, the oil pan, some of those Ford motors had all kinds of weird pans on them, and some of them were front sump. They always, the oil pump was up front.
Okay.
And then what the pan was in the back, and where the pickup was, and what he's going to do with the motor I don't know what he's doing with it.
Right.
Off-road, going uphill, downhill, where the oil pickup is at.
Oh, I see.
And the pans are really, you want that oil, a lot of times I see is a pan. We used to have some pans that had double drain plugs on them.
Oh.
So you had to drain the back pan, and you still had a bunch of oil in the front.
I see.
So you had to drain the front pan and the back pan to get all the oil out. Why would you drain half the oil out and put new oil?
No.
You had the dirty oil up front. So
okay.
There's a lot to that oil pan thing, and I think he should, spend some time on that.
Yeah.
Whatever his application is.
You're right.
Yeah, it's just common sense there.
Yeah.
But as far as the motor is concerned, I don't think I ever heard anything about any oil problems. Yeah.
Not for a normal situation.
Yes.
Okay.
Yeah.
Knowledge of 6 and 12 volt systems has eluded many technicians over the year. I made it a point to not only know where the wires went, but also know what they do. Ed's pretty close on his explanation, but I'm wondering about wiring the circuit for the coil during cranking. Now I know what he's talking about on old points because of the ignition switch.
Yeah, Chevrolet's the only one that has that. General Motors thing, and I think they had an extra wire that went from the starter and went to the coil, so it would start on 12 volts. And then let go. As soon as it ran, then there was there used to be a little white wire. It was kind of a cloth wire.
Okay.
That went to the coil, and it would only run on 8 volts all the time you're driving on the road, but start on 12. Other than that, we've always ran the coil. The distributor don't make any difference what 12 volts or 6 volts, the same distributor. It's the coil makes the difference.
I see.
So you want to put a 12 volt coil on a 12 volt thing, and we usually like to run resistors, this little resistor up on the thing. They start just as well.
Yeah. Okay.
So in our Flathead Fords, if he's asking about that, we'll run a Flathead Ford distributor with a 12 volt coil with a resistor and the ignition system, yes.
And what's the resistor? What circuit is the resistor on?
The positive going to the coil.
Positive to the coil. Okay.
Yeah,
I just want to be 100% clear.
And most cars have that.
Yeah. A guy named Kenneth says, totally counterintuitive, but points always seemed to make more torque versus the later Hall effect dizzies. Points ignition versus electronic ignition?
I think something like that. Depends on the application again. Usually, some of the older people like points because it's easy to diagnose. If they won't run, it's fairly easy. Like I just said in my video before, with a little sandpaper, sand the little carbon off there, the slag off of them, make them new. Sometimes the rubbing block has got a Lobes on the distributor, and it's got a little plastic rubbing block that rubs on those and opens the points. If you don't grease that thing and service it like it's supposed to be, that cam will wear the rubbing block off and the points won't open. So it's fairly easy to find that out. But electronics, how you diagnose the electronics, what's wrong with it?
Right. Then you need a computer.
Now you need some test equipment to find out if you're getting voltage there and you're getting voltage back the other way. And then it's also, he's talking about a little bit about this lobe thing. It takes a while for that cam to go around and open and close that point.
Okay.
And an electronic has got an electronic magnet in it. And it has sharp things in a rotor would be, or the ring would have sharp things that would go past a magnet thing and ignite that coil twice as fast.
And send the signal.
Send the signal twice as fast.
Right.
And a little bit more correct.
A
Yes.
little more precise.
Precise, yes, on electronic.
Okay.
And they're easy to wire. We wire them up all the time, and it's nothing, no secret about that. It still has to have a coil.
Yeah.
And the 2 wires go to the coil and 1 go to the ground, and that's about it.
Right.
But it is more precise. So some people like that.
Yeah.
And I put them on all the time.
Yeah. Okay.
I like the ignitions.
All right. Well, here's the last question of this episode. Okay. And it's kind of talking about cams, and we've talked about roller and flat tappets and things like that. I don't know this person's name, but they say cams will always become worn out and flat. The problem will not go away. You cannot harden the cam to the hardest Rockwell and expect it to survive. If it's too hard, it'll shatter. That's why cam lobes are hardened to a point where the inside is soft and sort of flexible to prevent shattering. Have you ever heard of shattering? I haven't.
You see them chipped.
Okay.
So you see a lobe sometimes. It used to be nice and shiny, perfect ground and everything else. You take one apart, it's got a little chunk taken off of it. I think that's casting. It's got nothing to do with the cam wear or anything.
Okay.
But in a casting, anytime you play with a casting, heat it and cool it.
Right.
Heat it and cool it, heat it and cool it many times, it's going to come apart.
Yeah.
Because it is a pressed material poured casting in the cast. It's going to come apart. That's like we've had motors that say that they have $100,000 on a block, a motor, and we clean it and everything else. And once we clean it and wash it with our power washers and stuff, it's got a hole right inside the motor.
And you didn't know it was there.
It was there. It was fine for 100,000 miles until we cleaned it, or else it became hot and cold, and the whole part of that casting was a flaw in the casting originally when they cast it 30 years ago, and now that casting, the hole falls right out.
Wow.
It's not uncommon.
Okay.
That camshaft's the same way. If you have it long enough and heat and cold, it's going to come apart.
Right.
But shattering, I don't know how you can shatter it besides.
I think it sounds like the point is
they are going to wear out.
Yeah, eventually.
That's the point. It's not going to live forever.
Right. Eventually they will. We'll agree on that.
Buy a new one. Try to buy a good one.
Get a good one, huh?
Yeah, and buy a good one and lube.
Right.
We have so many questions in the last 5 years on lube and camshafts. And I'm not sure. We do the best we can. And even, let's just touch a little bit about the lifters now. And we blame more camshaft failure on the lifter than we do the cam. The cam company, we argue with them all the time, and they have some good answers for our arguments.
Yeah.
They really do, trying to make their product as good as they can through arguments.
Yeah.
But anyways, we think it's the lifter problems more than anything else. And even one guy thought that we lubricated them so much with the new lubrication that the round lifter runs sideways on a cam. And it makes that lifter spin around and around and around. And so the new lubricate in a camshaft with this high tension on your valve springs and the rocker and everything else, it's got some pressure on that camshaft that the lubrication is so much that it won't spin the lifter.
Okay.
So one guy even mentioned he takes sandpaper and roughs up the bottom of the lifter.
Just to help it get some grip?
Yes, so it gets started on a brake end.
Interesting.
Because it runs sideways and it's got to spin that lifter.
Mm-hmm.
On a good motor, you'll see the whole push rod spinning.
Right.
Yes. And I think that's the early Chevy motors, 6 cylinders, they made that lifter off-center more. And so some of the camshafts in the design of the motor moves that lifter over and over closer to the cam rotation. Makes it spin so much that we don't see the push rod spin anymore.
Yeah, because you want that push rod to stay shiny from spinning around. And
that's right. It keeps everything moving.
Yeah.
One of the guys told me, he says, everything in the whole motor moves. The rings move, everything. You don't line them up. If you line them up today, they're gone tomorrow. He says everything moves. And if you think you're going to keep it from moving, you're going to break it.
Right, right.
So let it move.
Let it move. Yeah.
But I think some of our camshaft problems, again, we're going to go back to maybe some of this lubrication with the pressure on and stuff, the lifter won't move.
Okay.
And with it will go flat within 5 minutes.
Wow.
Sit right there and run that lifter.
Yeah. Wow. Okay.
So we're into that when I'm not so much, we're going to have to get together with my friend Lake Speed.
Yeah.
If I can find him, I think he's
on the run.
He's on the run.
He knows Ed Smith's after him.
Yeah. He's such a good guy, but he's on the run and he knows 5 times more than I know about, but I need to track him down and upgrade my education.
There you go.
That's what I need to do.
That's what we're all trying to do here.
Yeah, we're good.
Well, Ed, thank you for educating us on so many of these things and also your opinion on some of these things.
Yeah, I hope everybody enjoys it.
Well,
and so some of these days, we might make $1 or $2 what we're doing.
Yeah, you know.
I see some of these other guys making some sponsors and stuff like this. I wouldn't mind having a good sponsor. I don't need the money.
Yeah.
It would be kind of fun to have somebody pay me sometime.
It'd be nice for someone to buy us a cup of coffee, right?
Yeah, right.
Or buy one of your hats. We've got some hats available.
Or they buy my lunch. My friends here in town buy my lunch all the time.
That's right. There you go.
We have a lot of fun.
Maybe that'll still happen. That might be in the near
we might
future.
have something.
Yeah, very good. Well, thank you, Ed.
Okay, good. Thanks.
And thank you all for watching, following along, and we look forward to hearing more from you and get more questions. That's good. Bye. There we go.
These guys.